All right, guys. So in this next video, we're going to talk about sound and how it's affected by different states of matter, a solid, a liquid, and gas. And a few of you asked questions about this. Well, how does the type of medium affect how sound travels through it? So that's what we're going to look at right now. Now, in order to do that, the big thing that we need to look at is how are solids, liquids, and gases different? And we actually talked about this a little bit a couple of classes ago, where we talked about the difference between a solid, liquid, and gas. And the basic thing is that a solid has particles that are really tightly packed together. And then, secondly, they have very strong intermolecular forces, right? There's bonds, very strong bonds between those that kind of hold the solid in one place. That's why when you move a solid from one place to another, it doesn't change its shape or anything like that because the bonds hold it very solid and rigid. Okay. The second state of matter we have is a liquid. Now, in a liquid, you start to weaken those bonds, but the bonds are still there, right? The molecules can't just fly around anywhere, but they are a little bit more free to kind of move around and change their shape and things like that. Now, what that means is that it's a little less dense than a solid usually. Volume, it can change its shape to fit the volume that it's put into. And of course, the fact that they are weaker intermolecular forces and a little bit further apart. Okay. The last one is the gas. And you can see my image of the gas here, where in a gas, the particles are much further apart. They have no bonds between them, so no intermolecular forces. They don't really affect each other at all, except for those times when they actually run into each other. So, one of the things we talked about in class is transverse waves. Transverse waves cannot happen in a gas, right? We talked about the molecules and how in a transverse wave, the molecules move up and down, and it causes the wave to move in a perpendicular, the energy of the wave to move perpendicular to the direction of the molecules. Now, in a gas, that doesn't work because as one molecule moves up, it can't move the other one up, right? It can only move it in the same direction. In a liquid, you've got a little bit of connection between those atoms or between those molecules, either weak intermolecular forces in a liquid or very strong intermolecular forces in a solid, so that when one goes up, it automatically pulls the other one up, allowing me to have that transverse wave. So remember, transverse waves only in solid and liquid, not in gas. In a gas, you can only have the longitudinal waves, which is when as the particle moves this way, it can hit a particle, transfer the energy, transfer the momentum, transfer the energy, right? All of those things that we've been talking about, transfer that in the same direction as the motion. Now, all of this is going to come in to be important when we start talking about the speed. Now, I'm going to show you a video here that I put together. This video shows dominoes, right? Now, the green is representative of a solid, okay? So when you have a solid, the dominoes, the particles are very, very close together, right? In a liquid, the particles are a little bit more spread out. There's a little less interaction there. And then in a gas, that's the blue one, they're further apart. And so hopefully you can kind of see that here. Now what's going to happen is I'm going to go ahead and start the video. This is going to be slow-mo. And what I'm going to do is I'm actually going to take the meter stick there and I'm going to strike the ends of those dominoes all at the same time. And what I want you to notice is how fast does the wave move through the solid, liquid, and gas there. I'm actually going to show you again because I want you to see this again. All right, but pay close attention to which one goes the fastest. All right, so hopefully you noticed that the green ones went the fastest, the red ones were the next fastest. It was close, but the green was definitely faster, and the blue ones by far were the slowest. Now we can connect this to waves moving through a solid, liquid, and gas. Waves moving through a solid, because the particles are all so close together, are going to move through faster than waves moving through a liquid. And both of those are going to be faster than waves moving through a gas. All right. Now we're going to make some connections to this in some later videos as well, but this will give us just a little bit of an introduction to what's the difference in sound traveling through a solid, liquid, and gas. All right.